Hello my dear VLSI aspirants, welcome to Deep Silicon VLSI YouTube channel. Let's have a good numerical on XOR operations. Without any delay, let's start the question. Let x1, x bar, x2, x bar, x3, x bar, x4 is equal to 0, where x1, x2, x3, x4 are Boolean variables, and this is the XOR operator. Which one of the following must be always be true? Guys, these are the options. See, if there are 4 variables, then how many combinations we get in the truth table? 16, because 2 power number of variables will be the total number of combinations for a truth table. Now, this x1, x2, x3, x4. Let's assume the output is y. Okay, now the inputs, it could be 0, 0, 0, 0 to 1, 1, 1, 1. Okay, now let's see here. If the variables are 4, the inputs could be either from 0, 0, 0, 0 to 1, 1, 1, 1. Guys, here you see from the options x1, x2, x3, x4 is equal to 0. How this is correct when inputs are all ones? Let's take one combination. When all the inputs are 1, 1, then is it true? No, because 1 into 1 into 1 into 1. Then it is 1 only now. It is not 0. Even you take 1, 1, 1, 1, which satisfies this condition, because 1 XOR 1, 0. 1 XOR 1, 0. 0 XOR 0, 0 only. But still this condition is satisfied. Hence, we can say this is false. For the input combination 1, 1, 1, 1. Even for some of the combinations as well, you will get like the output as 1 also. It is not like always it is 0. Similarly, you take this x1, x3 plus x2. 1 into 1 plus 1. You will get 1 only now. Hence, this is also false. You can take few more combinations also, but even for one combination, if it is not valid, then that will not be the answer. Now even you take the fourth one, x1 plus x2 plus x3 plus x4, 1 plus 1 plus 1 plus 1, then it will be 1 only. These are logical additions. Hence, this is also false. Okay guys, now you take the third one, x1 bar, x3 bar. It is like 1 bar 0 XOR 0, 0 XOR 0, 0 only. Similarly, x2 bar 0 XOR 0, 0 only. Yes, here this condition is satisfied. For even 1, 1, 1, 1 combination also, even you can ask me, sir, for 1, 1, 1, 1 it is like satisfied. But what about the remaining combinations? See, here for one combination it is true, but he cannot give you the guarantee. For that reason, you can go in another way also. What he told, that is x1 bar, x1 XOR x2 XOR x3 XOR x4 is equal to 0. Now you take x1 XOR x2 XOR x3 XOR x4 is equals to 1, right? Now here, why don't you change this interchange? Why don't you interchange this? Because for XOR gate, commutative property is allowed. Hence, it is x1 XOR x3 XOR x2 XOR x4 is equal to 0. Now guys, here what we can say is this x1 XOR x3, isn't it? Here for the two inputs, let's consider this. From the properties of XOR gate, if you apply complement to both the inputs, still it follows XOR operation only. Hence, you can rewrite it as x1 bar XOR x3 bar. Similarly, x2 bar XOR x4 bar is equal to 0. Now you move this term to that side and you move x0 this side, then it is x1 bar x3 bar XOR 0 is equals to x2 bar XOR x4 bar. Now guys, we know very well XOR gate can be used as a buffer when one of the input is logic 0. Now here this x1 bar XOR x3 bar whole XOR 0 is x1 bar XOR x3 bar is equals to x2 bar XOR x4 bar. This one. Hence this condition is true as per the given statement. Hence we can say option C is the right answer. Right guys, this is about the question on XOR operation. I hope you like the video. Everybody please subscribe our YouTube channel Deep Silicon VLSI. Like, share and comment. Yes, we want to hear from you regarding the video, question, explanation, anything. Do you have a question? You want me to explain? Sure. You just get back to us. Sure, we'll come with an explanation. Right? See you in the next video. This is Shivaram signing off. Jai Hind.